Hello, much better. Thank you. I'm going to present a scalable SIP server. Kind of difficult job thinking about the previous presentation because we are sitting somewhere in the background, not having nice desktop interfaces or whatsoever. I hope it will be interesting anyway. Shortly about the history, we started in a research institute in Berlin quite some time ago. Originally, the project was named SIP Express Router, which was kind of de facto implementation for SIP routing at that time, and is still like a reference in the open source world. We created a branch by 2005 during some, let's say, more political discussion within the old project, which was named OpenSER. And actually, we discovered that you get a quite good and big project when someone sues you because they say you infringe some trademarks. So we had to change the name in Kamailio by 2008 because a US company claimed we infringe the SER trademark they have registered. However, although we started a branch in 2005, now we are working again with the original team under so-called SIP router project starting by 2008 because we discovered that we can share a lot of knowledge and efforts mainly to the SIP area, and we keep kind of direction, self-direction, mainly related to user provisioning and architecturing of the backends as extensions. So just to give you a feeling of how the web pages are looking for all these projects, and sites, Kamailio.org and SIProuter.org, with short screenshots down. The pointer is, sorry. In terms of development, we are using Linux. We use C because it's a real-time communication engine. We have to be fast. We focus on scalability. Just to give you an idea, right now we are able to set up a couple of thousand calls per second. We talk here about setup, so imagine like 10,000 people calling in the same time and one usual server can deal with. And we use all free tools available there to build very fast libraries in terms of parsing SIP messages, routing, doing list cost routing, doing load balancing, doing location of the users, all those core features for a SIP server. As administration and organization of the project, we are very community driven. There is no big company behind the project. We have kind of management board based on individuals from different companies, from different countries, so we are pretty worldwide established. And we don't have actually much activity there because we try to focus on development, not on political discussions. Last year was a pretty good one, and we got some nice awards out there, and it was not by luck because the project right now serves couple of most biggest deployments, and we have some of those that are in charge or guilty by deploying this in some corners of this room. I want just to mention 1&1 in Germany, 1&1 that right now they have over 3 million subscribers because they just integrated with Freenet. So probably there are over 3 or close to 4. SIPgate, another very popular VoIP provider in Germany, it's using a solution based on this project, but also other projects that are present also here after my talk, like Asterix and other examples, just to give you an idea. Telio in Norway and Switzerland, Truphone, which is actually doing voice over IP for mobile devices, which is very interesting right now, and mobile communication is going to grow more and more. Shortly about the features, because right now we have over 150 extensions, so I cannot list all of them. It's basically a SIP server. We don't deal with media. It's about signaling level, and most of the work we do in the application is when the call is established, to do authentication of the user, to do location discovery for the destination, to apply all these fancy rules right now you want for your calls if you are in vacation or redirected to a voicemail or to your secretary or whatsoever, and applying a lot of filters. Maybe you don't want to allow calls from the people that are not in your contact list, and so on and so forth. And we are going more and more as an application server because communication is no longer voice or video. A lot of people like to add more instant messaging presence, like you saw in the previous presentation. These are very important aspects of today's communication, and of course, integration with social networking. We are not a SIP phone because there are other guys doing this better, like Emil and the SIP communicator team. And also we are not a media server or a PBX or a back-to-back user agent, because there are others doing this good job and they are going to present after me. So we are somehow in the middle. We connect users with services, and we scale platforms to the large number of subscribers. One of the most important, as everywhere with the project, is the interface, because this allows to add a lot of features without affecting the core. We are in telecommunication business, where the most important aspect is to be fast and connect, because it's not like with email. If you stay and listen to nothing for about 10 seconds, you said, oh, what happens? You have to give a feedback quickly, because this is real-time communication. Also, telecommunication is for emergency services. If someone is going to die, it's not going to wait 1 minute to get, okay, we are trying to find the closer service to you. So we try to keep a reliable, small core, and if you have fancy ideas, you can implement it as module. We implement all these basic requirements from the SIP protocol, like SIP proxy, redirect, registrar. Then we have extension for the telephony service, like integration with enum numbering or connection to LDAP directories, advanced routing for list code routing, load balancing, couple of variants. We do support a lot of transport layers. If you want to communicate secure, you can use TLS. If you have a smaller one, you can use UDP. And we have a lot invest in the last month in the SCTP, because scales in terms of multi-streaming, multi-homing, this kind of features. We are not tied to a specific backend, because we have to host a lot of records. Think about username, password, blacklist, whitelist, where to redirect your mobile phones, so you can use any kind of database which is more appropriate for you. You can interact with the service via control interface like XML, PC. We have some extension to gateway with XMPP, another open specified communication protocol. And now I'm going to present, and this is the main topic for this presentation, the latest version 3.0, which is 3 weeks old by now, which was actually the result of the collaboration within the SIP router project. Just to give you a comparison with SIP router project, because now we have Kamailio and SIP Express router. coming out of SIP router project is more like with Linux distribution. We have the kernel, which is the parser, the router, and then we have a set of modules that we package and release Kamailio, and there is another set of extensions that other team release as SIP Express router. The first thing was to clean up a bit the architecture, because there are a lot of deployments using the project on embedded systems to optimize the traffic, for example, in Wi-Fi networks to find the best path to a service. And there you have to be very small. So we moved out a couple of core components as libraries to make it more flexible and smaller in footprint. So actually the core, if you think like Swedish buffet, doesn't do much thing. It's like an empty plate. And then if you want to be a very scalable load balancer to dispatch thousands of calls per second, you just load dispatcher module. If you need a least cost router to route calls to the cheapest alternative of your termination providers, then you use appropriate module. So basically you can be very, very small in providing some services in footprint. As I said, a lot of effort was on the transport layer, because in the past it was about voice. That was very easy. You just establish a connection and the hard job was done by the RTP. But now we have instant messaging, we have a lot of presence, we have people with hundreds of contact lists. So now we have to use more and more TCP to exchange this information. And of course we have to to protect their privacy. So we actually have to use TLS. And now we have the platform bigger and bigger in terms of number of servers. So inside the platform you can use HTTP with multi-homing, multi-streaming that gives a very good scalability service. Also, in terms of hiding your internal network, there's an extension to mask some privacy headers into the C messages, topology hiding, and also number portability, as more and more prefer to take their numbers from provider to provider. DNS caching, all basic, actually, the root of the routing over the internet is DNS. If DNS is slow, you feel like connection is slow. So we have here very good implementation to speed up all this one. Better control interface via XML RPC, reload of the config. You don't need to restart if you want to change parameter of the configs. A better structure of the routing block via include files, def and def some parts of the config, the C style of defines fallback from very fast or lower resource usage transport protocols like UDP to TCP or TLS if it's the case. So quite a lot of improvements. It's hard to list all of them. And beyond VoIP, we do a lot of extensions in the terms of presence and instant messaging, even enable all telephony devices via user location to show active online, offline states. Links if you want to check more about what's new. And although it's like 3 weeks old by now, it's still a lot of new for the upcoming release 3.1. And I invite you to visit the website. Not all of them are listed here, because in the last week we have like 2 other addition, Python API and the debugger for the configuration file. So this is, let's say, a quick run to the project, because it's a lot to talk about it. And I'm just in time. I will take questions on side of the room or outside if you have. Thank you.